On this first one, let me do this two ways. I could subtract the 2x. Not a bad idea, because then that keeps my variables positive. Subtract the 2. Divide by 3. So I get x. I get negative 3 greater equal to x, which means x is, if negative 3 is bigger than x, x is good. So the mirror image to turn it around, right? Turning that around is a very good idea, because if you don't, you normally shade the wrong direction. So now if I want to graph this thing, it's got to be less than or equal to negative 3. So what am I going to put on the negative 3, and which way am I going to shade? Good. Bracket. I'm going to shade down from there. So how does that translate into interval notation? What do I go from to? Yeah, from,
infinity.
Careful.
From minus 3.
Negative infinity up to negative 3. Bracket on the negative 3, just like on the graph. And infinities always have parentheses, because you can't get there. Right? And if you do, you got to let me know, because that would be really cool. I want to see it. Yeah. This is the graphical answer, and this is the interval notation form. Good. Anybody do this a different way? Yes. Okay. A few of you guys. So the other way to do this problem is to maybe subtract the 5x. So you get negative 3x minus 7, and then add the 7. And then you divide by negative 3. Now, this is what's going on in all your minds, but a few of you guys forgot when this has to happen. The thing is, I want you to really understand, if I move the x's this way, I effectively flip the sign because I put them on that side. So if I move them the other way, the sign itself has to flip to make it consistent. And dividing or multiplying by negative is what's called a non-order preserving operation. Oh shit, let me say it again. It's a non-order preserving operation. What do I mean by that? Which one of these is bigger?
1.
Okay, now divide by negative 1. What do you get? 2, and I get... Now which one's bigger now? Okay, so what happened to the sign? It flipped. So this is almost where as soon as... Why do I have to flip the sign? Because you do. You have to. Why? Because it's just the way numbers work. When I divide and multiply by negative 1, I change the side of the number line they're on. You with me? So that means that now the other guy is bigger. So what are variables? Numbers I don't know yet. So they have to act the same exact way. So when I divide or multiply by a negative, I'm divided by negative 3 here, the sign's got to flip. And thank God it does, because then it's the same answer I got earlier. So here I switch the whole equation. There, to make it consistent, I have to flip the sign, really. And now, of course, that will translate into these same way.
Because I did it from the beginning, and you told me to put it down. Because I just remember from my other teacher, he's always said to just flip it from the beginning, so you know, so you don't forget to do it at the end.
Oh, no.
Doesn't matter?
No. Because then you have to, it really depends on how you solve it. And so if you always switch it, you might solve it in a way that didn't need to be switched then. Do you see what I'm saying? So to me, that doesn't make any sense. Because if there's more stuff going on, maybe all the x's make themselves positive, and I don't end up dividing by a negative, so I shouldn't have switched. So I only switch the minute I divide or multiply by negative, the next line I switch it. Here, I divided by 3, not negative 3, so I did not switch. I know that 9 is negative, but I divided by a positive number, so the sign does not switch. You with me? Yes, ma'am.
I have a question. So I get the sign, just I multiply or divide by negative number.
That's it.
With x or with any number? Maybe.
Anything. For any reason. If I take an inequality and multiply or divide both sides by a negative number, for whatever reason, just because I feel like it, the sign has got to switch. Why? Because it does. Okay, everybody cool with that? Of course, that would have the same pictures and stuff. Here, this is a triple-sided monster, right? The left side, right side, inside. So whatever I do to one side, I have to do to all sides. Just in equations, we have two sides, so we always say the other side. Here, we've got to say all of them. So what's the very first thing I want to do here? Add 6, so then I add 6 everywhere. Now, I did this kind of on purpose. This 0. It's not gone. It's 0, right? Which is less than 3x, less than or equal to 27. And so the last thing I do, divide by 3. So then I'm going to get x is in between 0 and 9. So then to graph that, it's exactly what I'm... 9. What am I going to put on the 0? Good. Parenthesis. Right? Open circle, just parenthesis. What do I put on the 9? Bracket, because it's like the letter I for include. So bracket. And of course, a shade in the middle. I call this a sandwich. Right? It's sandwiching all the answers in between. And then interval notation is stupid easy here. Parenthesis 0, 9 bracket. Right? It's exactly the way it looks on the graph. Okay, sweet.
Why did you go that way if the arrow's facing that way?
You got to be careful. And that's why up here, the mistake people make when they see this is they shade up. When this actually says x is less than this. So your question really, this says x bigger than 0 if you read it the right way, right? This is 0 smaller than x, so x is bigger than 0. But it also has to be less than 9. So that's why it's sandwiched in there. The sign is not what you look at. It's the relationship between the variable and the number you look at. So in that first part, x is in the wrong place in a way. That's why it looks like it's shaded the wrong way. I do that a lot. I do. I know. Okay. So that's basically 9-2. Oh, and of course 9-2 has a little thing known as word problems in it. Oh yes. Everyone's favoriteest thing. You guys have all this here? So let's do a few examples of word problems. I think we'll get, let's see, where am I at? Line 4, hopefully I get to line 4. We'll see. We'll see how far I get. Let's start off with a nice visual problem here. The perimeter of a rectangle is 60. Oops, sorry. It's 28 centimeters. The width is 5 centimeters less than the length. What are the dimensions? What's the length and the width? Oh, I forgot the factors. Sorry.
Can you repeat what you wrote?
Oh, yeah. The perimeter of a rectangle is 28 centimeters. The width is 5 centimeters less than the length. What are the dimensions? Cool. The day that I can't read back what I wrote is the day I need to stop. Some of you guys are like, already? No, Jeff, you probably should stop. I can't read. A really good idea on this problem is to draw the picture. Yeah. The first step on a word problem, if it's not draw the picture, it's what are the players involved. So a lot of people try to jump directly to the equation, and that's insane. You will always do something wrong if you try to do that, unless you're really good with this stuff. What are the two players involved in this problem? Length and width. I love it. So we got length, we got width. one of them will always be x. Because we don't know either one of them, but they can't both be x. What's wrong with making them both x? What's that telling people if I make them both x?
The same thing.
I'm telling people that they're the same.
Same thing.
And then I have a square, and I don't know that. Shit. So be careful. X is something I don't know, but the minute you make something else x, you're saying they're the same. But it doesn't mean you want to make them x and y. Screw that. We're not quite there yet. But which one is going to be x and y?
Why? Wait.
I mean, y, w-h-y.
The width.
Yeah, look at this sentence here. The width is 5 centimeters less than the length. So who do I have to know first? I've got to know the length first, because then I can take 5 away from it to make it the width. So the width is a mess on the length. And I've got to know the length first. That's how I always... Figuring out what is just x is really the first most important part. If you call the wrong thing x, you're going to get the whole damn thing screwed up. Right? So the length, the width is something to do with the length. So the length has to be x. And now once I give the length that name, I can give the width the appropriate name. 5 less than that. X minus 5, 11. Don't say 5 minus x. That's where you start to get neat things like the width is negative 10. What? So 5 less than the length. I could never have written that down unless I knew the length was x. Okay. I like it. Now here's the next big mistake people make on this specific problem. People tell me that the equation is that. Now some of you guys are like, yeah, that's what I thought it was going to be. What's wrong with that? Perimeter tells you to go all the way around. You've only gone halfway. So for some of you guys, I want to tell you, you could then make this just 14 and it would work. But let me be careful. So let's label my picture. The width is x. The length is x. The other way around. The width is x minus 5. The length is x. So to go all the way around, I've got to have x plus x minus 5 plus x plus x minus 5, right? So I'm just missing. So that's not right. Okay, cool. So be really careful on these perimeter of rectangle shapes. People always make the mistake of going halfway. Because your brain says, oh, we got variables, let's just put them together. But you got to go all the way around. And now you got just an equation. This should be the very easy step. Hard step should be getting there. So now I just got a 4x minus 10 is 28. Well, that's disgusting. Oh well, too bad for us. Yeah, plus 10.
Divide by 4.
Divide by 4. So you can cut that in half. You can reduce it. 19 halves. I don't know if they meant to do that, but oh well. Too bad for us.
I have a question.
Yeah.
Rather than just write x plus x minus 5 plus x minus, can you just add 2, or multiply by 2 to both sides? To make it
Yeah, you could. Yeah. You could do 2x plus 2x minus 5. Yeah. The reason I'm careful, because most of you guys know that perimeter formula. In reality, you need to know 0 perimeter formulas. You should know no perimeter formulas, because perimeter is just always add up all the sides. Mm-hmm. So I know some of us already know 2w plus 2l and all that kind of crap, but you don't need that. Just add up all the sides. It's just, don't waste space memorizing stuff you don't need. Yeah.
Where'd you get 19 halves?
Reducing. Divide by 2.
Oh.
Yeah. And then what's that tell me? The length is 19 halves centimeters. So what's the width? 19 halves minus 5. So 9 half centimeters. Now you check your work. You add up 2 of these and 2 of these and make sure that they equal 38. Or 28, sorry.
19 halves minus 5, where did you put 10?
Say again?
Why did you put 10 right there?
Because 5 over 1 is 10 over 2. I was just skipping a step to make LCD.
Oh,
Yeah.
okay.
I'll do that every now and again, so feel free to ask me what the hell I just did. But I had to make LCD to get those together. Once you figure out x, you don't stop there. This is not solving an equation. This is answering a word problem. Word problems most of the time have more than one part. So 2 things. Make sure you answer all the parts, and make sure you give me the units. I will be a complete dork, and if you don't give me a unit, I'll put your shoes, bananas, what the hell are you saying? Yeah.
I just got lost at the bottom part right there. We have 19 over 2. Where did the next half of that come? Minus the 10.
All right, so x is 19 over 2. Yes. And the width I have to subtract 5. To be able to subtract 5 from 19 over 2, I have to have LCD. So I just doubled that so it can be over 2. Cool. And that's where I got the 9/2 centimeters. Cool. Is that all right? Semi? So the mistake people always make is they skip this step. Very often when they skip this step, their brain focuses on x minus 5. And so actually I sometimes get this equation from people. Right? They see the 5 less than something. Okay, x minus 5. They see the 20. Okay, equals 28. X is 33. Right. No, it's completely wrong. Right? You haven't involved all the pieces that are in this. So you want to list the pieces, give them math names, and then do to those names what's supposed to happen. In this case, adding all the way around equals 28. Let me see. Let's try another one here. Let's do one that's not so visual.
Is this still 9.2?
Yeah, in the white book it's 9.2. Price of plywood rose 5% to $42. What was the original price? Price of a piece of plywood rose 5% to $42. What was the original price? And I will help you out in one way. You will not get to the answer by taking 5% of 42 in any way, shape, or form. That is wrong. So try again. So in this case, what's x going to be? I love it. X is the price of plywood. Oh, let me do it this way. Now, here's the key. I do not take 5% of 42 and then subtract that to get back. I can't. Because to get to 42, what did I do? I took 5% of the original price and then did what with that? So if I have a shirt that costs $20 and they mark it up by 5%, how do I find a new price? 5% of 20. That's not the new price. Too bad. I wish it was. That'd be nice. Let me get 28 of those. Yeah. And then you add it on top of what the price was. So to get to this $42, where did $42 come from? It came from the original plus 5% of, and how do you write that mathematically? Math doesn't like percentages. That's something humans made up. 0.05. So the price increased by 5% of what it was to get to the new price. Holy shit. Right? So the mistake people make on these kind of problems is they apply the percentage to that number. That has nothing to do with it. That number, I can't get back to where I was by taking 5% of it, because how did I get to it? 5% of something I don't know. So now this problem might be a little bit weird. What's a whole x plus 0.05x? 1.05x. Good. And then how do you solve? Divide. the hell that is. $40? There's a long way to go for a nice round number. How do you check yourself? Check yourself. Yeah. So if it's $40 originally, it goes up by 5%. What's 5% of 40? 2. And what's 2 plus 40? 42. Sweet. If I take 5% of 42, what do you get? I get $2.10. I get 10 cents too much. If I subtract that from this, I'm not going to get to the real original price. I'm going to go more than it. Why? To get to 42, I took 5% of a smaller number. If I take 5% of 42, that's going to take me back too far. It's 5% of a bigger number. Do you guys kind of see what I'm saying? That's why that's a mistake. It will take you back too far. If you're just trying to estimate, that works. But if I want the right exact answer, that's it. And of course, I'm worried about the people that forgot what it was. We increased it by 5. What was it? I don't know. Did you write it down? I don't know. So to me, algebra problems very often are kind of dumb. Like the guy that put money in the bank, and he's like, how much money did I put in the bank? Well, I know I got this much now. Let's do it. I'm like, come on. Make a better problem. Okay. They don't get much deeper than that. There's some perimeter problems. Oh, tell me this. Angles in a triangle have to add to be 180. I love it. Right? You got like 30, 60, 90 triangles and stuff like that. Cool. So there are some triangle problems sprinkled in there. Okay, so I'll let you guys try that out. Let's do 9.3, and then maybe a little intro to 9.4, and then we'll head out. And for the McKee guys, what I just said was 3.1 through 3.4, and then 4.1, 4.3. Right. So 9.3 is all about graphing and functions. So this is where we come to the mx plus b stuff that we were talking about earlier. Let me just see what you know. Blah, blah, blah. Of course, one of these, we did an example like it earlier, but let's see. So in this first one here, I can just start graphing right away. What's the y-intercept? Good, 0, 3. Good job. And then what's the slope telling me to do? Yeah, it says down 2 over 1. I like it. So down 2 over 1. And just to kind of check myself, so down 2 over 1. Whatever point I end up with is supposed to do what? This point here, what point is that?
1,
1, 1. What should that point do? It should do my taxes. No, what should that point do? It should, well, when you plug it in the equation, it should work. So when you plug 1 in, does it work? Is 1 equal to negative 2 times 1 plus 3? Yes, negative 2 plus 3 is 1. You guys with me? Any point this line ends up going through needs to work in that equation. That's what it means for a point to be on a line. So if you do this, a real quick check is just plug the point you end up at in. If it comes off, then you went somewhere wrong. Right? So if you guys on the little warm-up sheet, you might have gone down 1 over 2 instead of down 2 over 1. If you did that real quick check, you would see very quickly that didn't work. I did something wrong. You guys kind of with me? Because the idea of slope, what is the idea of slope? Slope is, I like it, rise over run. And which variable involves rise and fall? Careful. Y is run, up and down. X is run. Have you guys ever seen that symbol there? The Greek symbol delta, it represents change. And what do you guys normally think of for the equation of a slope? Good, the change in y's. How much do the y's change? That's the rise or the fall. If it's a fall, it's going to be negative. And then, of course, the run is how much the x's change. The little 2 and the little 1, what do those represent? Points. The first point, the second point, I like it. Okay, hopeful. That wasn't too bad. Now, how could you do number 2? You could do it the same way by solving for y. You could get the intercept and the slope. But what's a slightly better way to do it?
Solve for both.
Good. Get the intercept. So the x-intercept. 4. And the y-intercept. Negative 3. And then you just plot those 4, 0, 0, negative 3, and whatever. Not a big deal. So if you solve for y, you should get 3/4 x minus 3. So down 3. So now it tells you to go up 3, 1, 2, 3 over 4. Hey, it's the same thing we got. Sweet. Okay. Good, maybe. Okay. So what about a little more interesting problems dealing with slope? What about... Oh.
I'm sorry, but should you only do it that second way if the numbers are neat like that?
Yeah,
and they
I
work
would.
Out,
I mean, if this was an 11,
then it's better.
I don't want to try to, plot 11 over 4. I don't want to, this one, for example, you could get the x and y intercepts, but the x-intercept would be 3/2. That's not too bad. That's 1.5. I can find that. But when you start getting down to the level of 3/7, I'm like, I don't want to find 3/7, right?
Yeah.
So it is kind of dependent on, is it going to be nice or not? If this was gross, I might solve for y and do it that way. Maybe it'll be easier that way. Yeah. Yes.
How do you get the 0 on the second one?
For the y-intercept?
Yes.
What do you do to find a y-intercept?
You plug in. Yeah, you put 0.
Put 0 in for what?
For y or for x, isn't it?
Good. So for the y-intercept, to plug 0 in for x.
Okay.
There you go. So automatically, any y-intercept, the x part will be 0, because that's how you get it. So when x is 0, y is negative 3. When y is 0, x is 4. So that's what that point actually means. That point actually tells you that whole thing. What was I about to do? Oh, yeah. What about this beautiful question? Find the equation of the line going through 1, 7, and -5. -5, yes, Jeff? I don't know. 1.
Would that be like finding the slope too, or?
Maybe so.
Like that.
Now, there are two main ways to do that, but just to help you out a little bit. One equation of a line that we know is mx plus b. Does anybody know another one?
Y equals y minus y
All right, we're getting somewhere.
equals m times
X
x
minus
minus x.
Because what does this really require? Intercept. This one just needs any point, right? The x part, the y part. That might be useful because here we don't have an intercept. We have 2 points.
Is that an n outside of the x?
That is an m. Cool.
That's point slope, right?
Good. That's point slope. Because math people are very creative. We have a point and a slope. Point slope. And this one, we have an intercept and a slope intercept. So you know. Really creative we are. Yes.
Does it matter if you put like x1, y1 on the y? The
You
one-
could, to keep yourself straight.
So,
There's nothing wrong with labeling this x1, y1, x2, y2. There's not a damn thing wrong with that. And there's not a damn thing wrong if you call this x2, y2 and that one x1, y1. Because think about it. If these both switch, they both become the opposite sign, and then those cancel back down to what it would have been anyway. So really, the only reason we have these stupid little 2's and 1's is so that you go in the right direction. You always have, if you do 1 minus 7, you have to do -5 minus 1. You have to go in the same direction. If you go the wrong direction on one of those, you're going to have the negative instead of a positive, or the other way around. It's going to be going the wrong way, the slope. Anyway. So what I always tell my students is, if you see this question, find the equation of the line, doing stuff, you think, I need 2 things. I need the slope, and I need a point. And you break the problem down into parts. And the people that are really good at math are the people that kind of naturally break a problem into parts. People who are bad at math are bad because if you don't break it into parts, it's almost impossible. You're like, do the whole thing. Oh, shit. How do I find the slope here?
Y equals mx plus.
Okay, well, that's where I want to get to, but how do I find that m? How do I find that slope?
Y2 minus y.
I like it. So I got y2, 1 minus 7, the change in the y's, divided by -5 minus 1. So it's very nice here. -6 over -6. The slope is 1. Shift? No shift. And then you pick either point you want. And you plug and shove. It's almost too easy. So I'm going to pick the point 1, 7. Just because it's the first point. Doesn't matter what you pick. Then I got y minus the y piece equals m times x minus the x piece. Alright, the y piece is 7. The m we figured out is 1. And the x piece is 1. That's basically the equation of the line, but then you clean it up a little bit. You solve for y. So you get y equals x. Add the 7 over. How do you check your work? You plug in, yeah. 1 plus 6 is 7. Sweet. -5 plus 6 is 1. Sweet. There you go. That's the right line then. Goes through those 2 points. Okay. Okay, some of you look bored. This is good. This should be a very basic review.
I didn't understand how after you got the point, what were you plugging in? Like, what equation were you using?
This guy here.
Oh.
And the funny thing about that guy right there, oh, it's so funny. You're gonna laugh. No. I just said earlier how this is kind of silly to give these little subscripts. This shouldn't matter what 2 points you pick on a line. Is this, if the slope is different, do you have a straight line? No, you have like a kink in it somewhere, or it's a curvy dude, right? So it shouldn't matter what my other point is. I pick a point, and then any other point, I should get that. Now, if you multiply this up, you get that equation. So that equation is just the slope definition rearranged a little bit. That's all that equation is. Okay, hopeful. So that's why I'm allowed to use this and just plug in what I know. It's almost too easy. We're like, that can't be it. Math is harder than that. Right? Or we're like, well, what the hell? I just put shit places and it works. Sorry, that's math right there. And it's got to follow an accepted truth. I take what I know is true, I rearrange it a little bit, and I go, oh shit, I can use that in other places. Okay. Yeah.
I don't understand this, the last expression. Y minus 7?
Yes. Y minus the Y piece.
Okay.
So what's the point I picked? 1, 7. So what's the Y piece? 7. So I picked this one. So Y minus Y1. Okay, Y1 is 7.
Yeah.
Equals M. Okay, we figured out M is 1. X minus X1, well, X1 is 1.
Okay.
And just to show, yeah.
Can I use this equation Y equal M?
All right, so let me show you how to use that.
But I was
So in this problem, it doesn't seem like you could, but let me show you how to use this equation for this. So we know the slope is 1. Now, to really do this equation, I have to get the intercept, and I don't have the intercept, but I do know x and y. I do know, for example, when x is 1, y is 7. When x is negative 5, y is 1. So if I plug in one of those points, y is 7 when x is 1, I can solve for b.
Yeah.
So when you subtract 1, b is 6. And there it is. I love it. So that is the alternate way to do this. Not a damn thing wrong with that way. And maybe. So some of you guys might be used to this method. Some of you guys might be used to that method. Either way, I don't care. Right? Either one that makes sense. If you have a third method, you better run it by me. Well, my method, Jeff, is to look at the piece and sit next to it. No, it's not. Is there anything else about that problem there? Okay. And the last piece of 9.3 talks about functions. And what the hell is a function anyway? Anybody ever seen, there's another puberty. Anybody ever seen the movie or ever heard of Highlander? One person, all right. So this reference is going to go over everybody's head. It's too bad. So really a function is defined to be something where for every input, there can be only one output. All right. Hey, I'm going to look at my one person. Hey, you got the reference in. So for every input, which is normally x is normally our input, there can be only one output. Normally y. So the way I relate this to like a physical reality, if I ask you what size shoe are you wearing on your left foot right now, and you give me two answers, what is happening? Right? Do you have more than one shoe on your foot? So if I ask you, Okay, throw a ball. 2 seconds later, where's the ball? And you tell me it's 20 feet in the air and it's also 12 feet below the ground. What did you just do? What happened here? Are you guys kind of with me? So in real world, many situations, I can have only one answer at a specific time. Now, you can have a rocket blow up, and so, but screw that. If the rocket stays together, it's going to be at a specific place at a specific time. It can't be in 2 places at once. That would be nice, but we can't do that. So this kind of follows reality then. You throw a ball, it's got to follow some kind of a thing. It can't do this. Like at this time, it was here and here and here. Right? That's not, how'd you miss that ball? Well, right before it got to me, it was in 3 different places. No, you were drinking or something was happening. What the hell? Right? There's like 5 balls. Which one do I catch? All right, that's free. So what does this really mean then? Visually, what I just did kind of is a nice test we can run on the graph. This is a graph of a function because I can't see anywhere that for any x it goes through more than once. There's just one place for that x. This input has this output. But if I have that other graph, so this is a function. If I have that one I just drew, then at this time here, it was here and here and here. 3 different places. That is not a function. And you can see there's a nice visual. For this input, there's more than one output. That's exactly what the definition does not allow. And of course, this is called the what test?
Vertical line.
Vertical line test. I love it. If any vertical line you can draw goes through more than once, it's not a function. If you can't do that, it is a function. Right? So this is the vertical line test. All right, so the minute we start talking about functions, we also have to talk about domain and range, right? And then function notation. So if I have a function that looks like this, let's say, let's go even further down. Let's go there. Alright. Let's see. I'm trying to force it to do what I want it to do, and that's never good. I'll screw it. Let's do that. Alright. So I'm trying to help you out here. The domain deals with which variable? X's. I love it. So domain is about what you plug in. Domain is about input. So the domain of this function up here is the x's that actually have outputs. So I would say, have a little dude walking on the x-axis. What's the first place he sees the function?
-2.
Yeah, -2. And he sees it, and he sees it, and he sees it, and then he loses sight of it. Now, of course, I went a little further than I wanted to, but I won't. He loses sight of it about there, 6. Let's make it 6. So the domain would be -2 up to 6. Those are all the x values that actually have outputs. Outside of there, there's no outputs. It doesn't exist outside of there. So domain would be from -2 up to 6. There's our good old interval notation, helping us say that. What about the range? The range must be about the y's, the outputs. So what do the y's do here? They go from to what? What's the smallest output that I see? Yeah, a little dude walking, he sees a -1, he sees it. And of course the highest output, 3. Cool. So there's domain and range that they give you a graph. So let me ask you this in a slightly different way. Oh shit, I'm basically out of time. One last question real quick. I didn't realize it was already time. is that a function? What's the definition of function? For every input, there can only be one output. So is there any x input that has more than one output? Yes. One has a 7 output and it has a 5 output. So this is not a function. But I can still ask you, what's the domain and range? It just isn't a function. But what's the domain going to be? Careful now. Yeah, it's going to be specifically 1, 2, and 3. I can't say 1 to 3 because then you're telling me that 2.5 works and 1.8. No, it doesn't. 1 works, 2 works, 3 works. What's the output? What's the range? -4, 5, 7, 9. Cool. All the outputs. This is different from that one. These are specific points. It's not lines in between. It doesn't include all the values in between. It's just specific values that work. Alright, and that's plenty. So we'll pick up from there next time.
For the
Sorry, do it again. So which book do you have? Mickey? So we made it up through 3134. Yeah.
I wanted to do it, but that's not
It's a part of the equation I got stuck on. You were going to
Okay.
I need to add them.
Oh, I guess, okay.
And I wonder if I can make an appointment tomorrow with you in your office earlier.
Oh, just come to my office out? Or do you want to come earlier?
Yeah, it's more early because I don't have a sitter. So I come at like 11:15 or 11:30.
11:30 should be fine. I should be in there. Yeah.
The same, you're over here in the corner store. When we
Where
go
are
5?
we?
Oh,
I'm
right
in the science building.
here. Okay.
I think my doctor's note, I wasn't here yesterday.
What about?
Do I have to add points to it?
You do. Remember, are you the one that
I emailed.
ended up dropping?
I don't know if you ended up dropping.
No, so you're probably, you told me ahead of time?
No, I didn't.
Oh, then I might have dropped you.
Let me double check that.
Yeah. Make sure if you're still in or not.
Yeah. See you tomorrow. 11:30.
It's recording. Yeah. Yes.
Yeah, I missed the first day.
Oh yeah, so you know which book you're going to use.
I'll write it down. I'll grab it right now.
It's either, I prefer this one,
Okay, what's that
but that's
one?
more expensive, and then there's this one. This is Bittinger.
And it has to be that edition?
Yeah, it has to be this.
Okay.
Cool. And then you would get that. So they should have used copies in Ross books.
Okay.
It's $54 there for a used one.
Yeah, dude. Because otherwise it's like 100 and something. So here's the
It's way
syllabus.
cheaper
Oh,
over
my God,
here.
it's probably up there.
The syllabus.
Oh, I have that.
Yeah,
Print
good.
that out.
All right.
And then name on here and take this.
Yep.
Excuse me? Can I
Yes.
take the homework for the blue book?
Oh, for the blue one?
For the new book. Or not the new one, the white one.
This one, okay.
Yeah.
You have for blue?
Blue? Yeah.
This.
The blue one, the white one. Ooh. Wait.
What homework?
Sure.
For the
Yeah,
but like, I don't know for what book.
Which book do you have?
The white one.
Okay. So then it's this.
And there for homework tomorrow.
For the October has on the wait list.
Through 3-1 to 3-4. Yeah, 2-1 to 2-4 should be done tomorrow. That's all as far as we made it yesterday. No.
That's great.
These are the dates that will be in here. That we'll be talking about these dates. Those aren't the due dates. The due dates are always a couple days after I finish talking about a section. So if I finish talking about 4-1, 4-3, it's due 2 class periods after that. Does that make sense? Yeah. But just keep working on it and give it to me when you're done.
About the white one, also the
Say again?
page, the homework for the white
Oh, so you're good. We just finished 9-3.
Just
So 1993, you should be working on it.
I just want to let you know that Sylvia Fox made it. How do we?
Oh, good. All right. So you have this book, right?
Yes.
All right. So you got that, and here's the syllabus, right? And you and you're in the class. But you had told me you would
Yes.
miss it. Okay. And then the video from yesterday is actually up on the website. You can click on the link.
Thank you very much.
I have a question. Since I started doing the homework, so I'm not getting it. So what's due? Is it like all this?
So like today, we just got up through 3134.
Okay.
So that homework would be due Thursday, 2 class periods later.
And
It's the hard set due date that I started counting as late is the day of the test. But I don't, please do not, don't turn it on the day of the test. The intermediate due dates are just so you know if you're on track or not.
so this
So
is
if you-
question 3 to 21, right?
Should be done tomorrow.
Yes.
Yeah, every third one.
And then
Every third one, so 3, 6, 9. Yeah. You don't have to do each one.
okay. So I need
If
to
you do each one, it's a little extra practice.
I need to do it again. So it's
You don't have to do it again, because you've obviously done that, you've done more.
okay.
Yeah.
So 3 to 21, every other third,
And that's 23 through 30 all. So 23, 24, 25. Yeah.
Okay, I wasn't really so can you sorry, I don't mean to make you explain. So every third one, and then
Yeah, so like here, this is every 5th one, so it'd be 5, 10, 15, 20.
okay, right.
You guys have different books, so don't freak out.
Oh no, I have that one.
6 through 48 every third one, so 6, 9, 12, 15,
Okay.
all the multiples of 3.
Gotcha.
Yeah.
And then we
5 to 6.
bring it into class every class or whatever, or every.
Yeah, so basically I finished 9-3 today.
Okay.
So technically that's due Thursday.
Okay.
I always make it 2 class periods later, so you have the class in the middle to ask questions.
Okay.
But by the day of the test, everything the test covers, that homework has to be turned in. You have until then. So please, do God, give it to me before. Yeah.
Thank you.
Sure.
You have a question? Mine's a math. It's like a.
Go ahead.
Math. Okay. So I'm just, I just didn't want to keep making
Yeah.
you hard.